Welcome to my viewers. Today we will discuss about real number systems. This is lesson 1 of class 9 CBSE curriculum. Now real numbers are broadly divided into two categories, rational numbers and irrational numbers. First we will start with rational numbers. Now let's recall the system of integers you studied earlier. You represent the integers on the number line. Starting from 0 to the right side you get positive integers, and to the left side you get negative integers, right? Now you see in between 0 and 1, in between two integers you didn't find any integer. In between 1 and 2 there is no integer. Similarly in between 0 and -1 there is no integer, but we will try to find some numbers in between 0 and 1. Similarly in between 1 and 2. Let's do one thing. Say for example you want to divide the line segment between 0 and 1 exactly into two equal parts. So let's bisect this line segment using compass. Now you join this. Now you see this point exactly in between 0 and 1. So you are dividing the line between 0 and 1. This is 0 and this is 1. 0 and 1 exactly into two equal halves. So each part will represent one half, right? You are dividing this line segment into two equal parts. Its length was 1 unit. This was 1 unit. Now since you are dividing into two equal halves, so every portion will represent one half. So this point will represent half. Similarly, if you divide the line segment between 1 and 2 exactly into two equal parts, this portion will represent again half of 1 and 2. In between 1 and 2 you will find this position will represent one half. This part is also one half of line segment between 1 and 2. Now what would be the position of this point? What is the position of this point? Say it is A. What is position of A? A represents 1 plus half. From 0 to 1 this is 1 unit. From 1 to A, this point, this is half. So 1 and half means 1 half. This is 3 by 2. So you get a number in between 1 and 2 like this. Similarly in between 1 and 0 and 1 you get, say this point is B. B represents half. Similarly in between 0 and -1, if you divide this line segment exactly into equal halves, you will get minus half here. Similarly in between -1 and -2, if you divide exactly into two equal halves, you will get -1 and half. That means -3 by 2. Thus we get a new set of numbers. Now you can keep doing this division in another way. Let's say one more example. Now let's say you divide the portion between 1 and 2 into 10 equal parts. Say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just like centimeter scale. Now in between 1 and 2 you divide the segment into 10 equal parts. This is 1, this is 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you see this position it represents 1/10, and this position represent 2/10. This from 1 to this length 3/10. So say for example you denote these points by A, B, C, D, E, F, G, H, etc. Now point A represents 1 plus 1/10, right? From starting from A, you see position of A is 1 plus 1/10. Since this portion represents 1/10 of the line segment between 1 and 2, so point A represents 1 plus 1/10. That means 10 ones are 10 plus 1 11, 11/10. Similarly, B represents 1 plus 2/10. Point B represents total length, 2 portion of the segment between 1 and 2. We are dividing this segment into 10 equal parts. B represents 2 portions of 2 portions of 10 parts. 1 plus 2/10. That means 1 plus, if you convert this into lowest term, 1/5. This means this 5 1 5 plus 1 6/5. Point B represents 6/5. Similarly, C represents 1 plus 3/10. 1 and 3/10. That means 13/10. D represents 1 plus 4/10. 1 plus 2/5. 1 and 2/5, or 7/5, and so on. Thus you can find any number in between 1 and 2. So this type of numbers we are discussing here. Now we define the rational numbers, a number which can be expressed in the form P by Q, where P and Q are integers. P and Q are integers. P and Q are co-prime, and Q not equal to 0. So let's remember this definition. A rational number is a number which can be expressed like in the form P by Q, where P and Q are integers. P and Q are co-prime. Co-prime means P and Q don't have common factor other than 1. Means they are only divisible by only 1. Means they have no common factors other than 1. And Q is not equal to 0. Right. So let's take one example. 0 is an integer. Now 0 can be expressed as a 0 by 1, or 0 by 2, 0 by 3, etc. So 0 is a rational number. 0 can be expressed in P by Q, where P and Q are integers. This is P, this is Q. Q not equal to 0, denominator should not be 0. In every case you see denominator is not 0. So 0 can be expressed in the form P by Q. 0 is rational. So let's talk about any integer. Say for example 2. 2 can be expressed as 2 by 1, P by Q. 2 and 1, they don't have common factors other than 1. 2 can be expressed as say for example 15 by 30 by 15, suppose 30 by 15. It is in P by Q form. but if you convert this into lowest term, 15 2 ja 15, 15 2 ja 15 1 ja 2 by 1. So you can express it as a p by q form. 3 can be expressed as 3 by 1 p by q. P 3 and 1, they don't have common factor, and denominator is non-zero number 1. So every integer even in -1 can be expressed as -1 by 1 p by q form. P and q are integers, q not equal to 0. They don't have common factors other than 1. So we understood one thing, that every integer is a rational number, right? Now say for example, can you find question, suppose find 5 rational numbers between 3 by 4 and suppose 3 by 7, right? 3 by 4, in between 3 by 4 and 3 by 7 you are given to find some rational numbers, 5 rational numbers. Now you see 3 by 4 and 3 by 7. Let's make them like fraction first. So 3 by 4 we multiply both by 7. This you multiply both by 4. We are just cross multiplying the denominators. Then they become 21 by 28. This becomes 12 by 28. Now you see, in between 12 by 28 and 21 by 28, you can find some rational numbers in between them. Say for example, in your class test, in your class, one student got 12 out of 28, another got 21 out of 28. Now you may imagine some students and they are getting more than 12 but less than 21. So you can imagine some numbers, say for example 13 by 28, 14 by 28, 15 by 28, 16 by 28, 17 by 28. Imagine these numbers. These numbers lies in between 12 by 28 and 21 by 28. These numbers are greater than this and less than this. So we find some rational numbers between 21 by 12 by 28 and 21 by 28. And if you convert them into lowest term, you get they have don't common factor. This you can convert into lowest term. 7 2 ja 7, 4 ja, that means 1 by 2, 15 by 28, 4 4 ja 4 7 ja 17 by 28. That is, you get 13 by 28, 1 by 2, 15 by 28, 4 by 7, 17 by 28. That is how you find the rational numbers in between 3 by 4 and 3 by 7. Now let's say find 5 rational numbers between 3 and 4. 5 rational numbers between 3 and 4. 3 and 4. Now you see, 3 can be expressed as a fraction, 3 by 1, or you can express it as a 30 by 10. Similarly, 4 can be expressed as a 4 by 1, or if you multiply both by 10, 40 by 10. Now we find that 31 by 10, 32 by 10, 33 by 10, 34 by 10, 35 by 10 lies in between 30 by 10 and 40 by 10. You see, all these numbers lies in between 30 by 10 and 40 by 10, right? 30 by 10 and 40 by 10. So we find some numbers in between them. They are 31 by 10. This number is greater than this. 32 by 10, 33 by 10, 34 by 10, 35 by 10. So we find 5 numbers in between 30 by 10 and 40 by 10. That is 31 by 10 means 31 by 10. You cannot convert into lowest term. They are co-prime numbers. 32 by 10, they are divisible by 2. 16 by 5. 33 by 10, this will remain same. They are co-prime. 34 by 10, they are divisible by 2. They are even numbers. 17 by 5. 34 by 10 and 35 by 10, they are divisible by 5. 5 7s are 5 2s are. These are the numbers in between 3 and 4. So to find the numbers in between 3 and 4, we are converting them into fraction. Then you can think of numbers in between 30 by 10 and 40 by 10. 30 by 10 means 3 and 40 by 10 means 4. So we find these numbers in between 30 by 10 and 40 by 10. These numbers lies in between 30 by 10 and 40 by 10. And when we convert them into lowest term, we got the actual real numbers, 5 real numbers, right? So say for example, instead of 5 numbers, you are asked to find more than 5 numbers. Say for example, find 20 rational numbers between 3 and 4. Suppose you are given to find 20 rational numbers between 3 and 4. Now 3 equal to 3 by 1, or 3 by 30 by 10, or you can say 300 by 100. We are multiplying by this by 100. These are equivalent fraction. 300 by 100 means 3. Similarly, 4 equal to 400 by 100. Now you see, in between 300 by 100 and 400 by 100, you can find 20 numbers, not even 20 numbers. You can imagine more numbers in between 300 by 100 and 400 by 100. So you can imagine, say for example, 301 by 100, 302 by 100, 303 by 100, 304 by 100, 305 by 100, 1 2 3 4 5, some more, 306 by 100, 309 by 100, 10 by 100, 11 by 100, 12 by 100, 313 by 100, 314 by 100, 315 by 100. So how much you got? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15, 16 17 So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you got 20 numbers in between 300 by 100 or 400 by 100. In between these two numbers, you got these numbers, right? Now you can convert some of them into lowest term. 300 by 1 by 100, they are co-prime. So that is, this number will remain same. 301 by 100. This you can convert into lowest term. They are divisible by 2. That means 3 15s are 151 by 50. They are co-prime. 303 by 100. They are divisible by 4. 3 4 7 are 28. 4 6 are 24 by 25. They are divisible by 5. 5 6 are 5 1s are 5 20s are. They are divisible by 2. 15. 153 by 50. 307 by 100. 308 by 100, they are divisible by 4. 4 7s are 28. 4 7s are 28 divided by 25. This is 309 by 100. They are divisible by 10. 31 by 10. 311 by 100. This is divisible by 2. 156 divided by 50, or again it is divisible by 2. 25. 2 7s are 14. 2 8s are 78 by 25. This becomes co-prime. They are divisible by 2. 15s are 157 by 50. 5 6 are 5 3s are 15. 5 20s are divisible by 4. 4 7s are 28. 36. 4 9s are 25s are 317 by 100. 15s are 2 9s are 50. 319 by 100. This divisible by 10. 32 by 10. Again it is divisible by 2. 2 16s are 2 5s are. Right. So we've got 20 numbers, rational numbers in between 3 and 4. This is the answer. So even if you want to find more than 20 numbers, say 50 numbers, you can convert them into fraction to make it convenient to find more numbers in between 3 and 4. That is how we can find infinitely many rational numbers in between two given numbers. So in between two integers you will find infinitely many rational numbers. That means in between two rational numbers there are infinitely many rational numbers. Now next question, find a rational number between 1 by 7 and 2 by 7. Now we say 1 by 7 equal to, you can say it 10 by 70. 2 by 7 equal to, you can say 20 by 70. Now 11 by 70 lies between 10 by 70 and 20 by 70. That is 10 by 70, this is less than 11 by 70, this is less than 20 by 70. Now 10 by 70 means 1 by 7, less than 11 by 70, less than 20 by 70 means 2 by 7. Therefore your answer is 11 by 70. This is how you can find rational number between two given fractions. We will discuss similar examples from CBSE curriculum. Say for example, find 5 rational numbers between 3 by 4 and 4 by 5. 3 by 5 and 4 by 5. Question. Find 5 rational numbers between 3 by 5 and 4 by 5. So let's make them equivalent fraction. 3 by 5 equal to 30 by 50. 4 by 5 means this is 40 by 50. Just we are converting them into equivalent fractions. Now you can imagine 3 by 50, some numbers in between 3 by 50 and 40 by 50. Let's say 31 by 50. This number is greater than 30 by 50, right? 31 by 50 is less than 32 by 50. 32 by 50 is less than 33 by 50, less than 34 by 50, less than 35 by 50, and this is less than say 40 by 50. Since we are given to find 5 rational numbers, so we are taking 5 examples. Now 30 by 50 means 3 by 5. This is less than 31 by 50. This if we convert into lowest term, 16 by 25. This is 33 by 50. They are co-prime. This you can convert into lowest term, 217 by 225. This you can convert into lowest term, 5 7s are 5 10s are. 40 by 50 means 4 by 5. So we find 5 rational numbers between 3 by 5 and 4 by 5, right? This is how we can find rational numbers in between given rational numbers. We will discuss similar example in the next class. Thank you for watching. Bye bye.